Okay, students. So this video today is going to be about how to do drug calcs, and it's a different way than you may have learned otherwise. So a lot of people, when they're getting taught drug calcs in paramedic school, they're taught a whole bunch of various formulas, like you have desired dose divided by something multiplied times concentration, yada yada yada, and those all work. But the tricky thing is you have to put all the right numbers in the right spot in the formula, and then do the math. If you get that wrong, like, it's all screwed up, and then you always get the wrong answer. And so this method, which I call the big line. I think it's also been called, like, someone told me it was the Stark formula. I don't think it's Tony Stark, Iron Man. I think it's a different Stark. I tried to Google that and couldn't find anything, so I'm not trying to say that I invented this, because I totally didn't. But it works really, really well for me and a bunch of people that I've showed it to in they're doing drug calcs in paramedic school. So I want to put this video together to show you how to do it. So the first thing that we have to understand is just a little bit of math. And so what we're saying is when you have a numerator and then a denominator, so we're going to do like, division, where we take the top number divided by the bottom one. You can always simplify things. So if you have 10 divided by 5, as an example, you can say, well, 10 is really, we could rewrite that as 2 times 5, right? Because 2 times 5 equals 10. And then when you're doing the big line method, anything you have on the top, if you have the exact same thing on the bottom, you can cross them both out. So we can cross out the 5s, and then we just have 2. And anyone with the calculator knows that 10 divided by 5 is equal to 2. So it totally works. But this is a way of making your math problems smaller and easier by breaking it down into small, separate chunks, rather than ending up with this giant numerator and this giant denominator and being like, I can't do that in my head, or I can't do that on paper. It's too big a math problem. We've got you covered. We're going to simplify the problem. So you end up with something like 1,028 divided by 400. Well, we're going to take that and we're going to say, okay, how can we simplify? How can we make that easier? Well, 1,028. Oh, I probably shouldn't have picked something so difficult. Oh wait, yeah. See, I can't even. I screwed this all up. 1,024 was what I meant. So 1,024, we can say that is 4 times 256. Trust me, it's binary. Like, that's the right answer. And 400 is the same as 4 times 100. So we're going to cross the 4's out. So now we have 256 divided by 100. And that would be this equal to 2.56. Because we just take the decimal place, we move it 2, cross the zeros. If you don't get this, like decimal places and stuff like that, look for another video by me, or I would totally recommend going and looking at Khan Academy. I know that Sal Khan has some really good math videos. I've put my son through a bunch of those. So if you're having trouble with some of the math stuff, this really isn't the video for that. Go check out Khan Academy and then come back to this. So I'm just going to erase the whole page here, and we're going to show you the big line method now. So get rid of all this math. Yuck, 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 right? Okay, so here's a good example of a math problem. So medical control says that your patient in septic shock, you are going to need to start a levofed drip. And so you're going to do levofed, and you're going to start this at 5. Wow, see, my handwriting's terrible. You start this at 5 micrograms per minute. All right, so now we have to get ready to do our big line method. And so you've got a 60 drop set. So it's 60 drops per ml. You've got 4 milligrams of Levofed in a bottle. You have a 250 cc bag of fluid. And we've got micrograms and we've got milligrams, so we're going to need to convert those at some point. And I'm sure you know the answer, but you have 1,000 micrograms and a milligram. And cc, I wrote cc here. Sorry if that confuses anybody. But you know, a cc is the same as a milliliter. So, all right, we got everything we need. So we're going to do the big line method. So what we do is we draw a big long line. And the reason that the big line method works really, really well is that the first thing that you do is you start over here on the left with what you're trying to solve for. So, you need to give 5 mics per minute of Levofed, but you need to figure out how many drops that is per minute because you're doing this the old-fashioned way. So the first thing that we need to solve for is our drops. So here's 60 drops in 1 ml because that's a micro drop set. Now we're going to put a separator in. And so remember when we were showing that if you had a number on the top, if you have 100, and you have the same number on the bottom, you can cancel those out. Or if you have a 2, 5, we can cancel those out because it's the exact same thing. So we can do the same thing with all of these units, and that's the key to this method. So if we have milliliters on the bottom, we can put milliliters on the top and then cancel them out. So if we look up here, we've got a 250 ml bag, 250 mLs, and we're putting 4 milligrams of Levofed in that bag, so we're going to put 4 milligrams down here. Separator, and so our milliliters cancel each other out. Now we got milligrams on the bottom, we want to get milligrams on the top, so we're going to do the same thing. Let's look up here. Oh, here's milligrams, because we use this one, we use that one, we use that one. So we're going to have 1 milligram is 1,000 micrograms. Cross out our milligrams. Now we've got micrograms on the bottom. So here's our micrograms. So we're going to have 5 micrograms per minute. And our micrograms cancel out. So we're left with 60 times 250 times 5 drops per 4 times 1,000 minutes. Obviously, it's way too big. We're going to fix that now. But our system's working. So we've got drops per minute. We know we're going to be solving for the right answer. So I'm just going to rewrite this. So we have 60 drops times 250 times 5 divided by 1 4,000, and that's 1 minute there. All right, so you probably know where we're going, but I'm going to do it anyway. So this 1,000, we can rewrite that as 4 times 250. 4 times 250 is 1,000. And then 60, we got a 60 up here. Well, we can rewrite that as 4 times 15. 4 times 15 is 60. So I'm trying to find some things that we can do a little canceling out to make our math easier. All right, so if we have a 250 here and a 250 here, we can cross those out. I'm going to cross stuff out in color now. So we're cross out the 250, cross out the 250. We got a 4 on the top, we got a 4 on the bottom, so we're going to cross this out. Cross this out. All right, so now we have 15 times 5 divided by 4. And so 15 times 5 is 75 divided by 4. And we'll just go ahead and bring up a calculator program. If I can find one on my iPad, I'm pretty sure I bought one. It's so weird that the iPad doesn't come with the calculator built in. Well, maybe I got to search. Oh, that's not the wrong way to search. There we go. C-A-L-P Calc. There we go. Okay, so what did we have? We had 5 times 15 divided by 4 is 18.75. So 75 times 4 equals 18.75. Oh, I should be drawing up. See, goes 8.75 drops per minute. So my paramedic school, you had to do everything out to the decimal places. Obviously, in the real world, you would round that and you'd say 19 drops a minute. But anyway, this is the big line method. Let's erase this page, and I'm going to show you why the big line method is so awesome, because it works for very complicated problems like this, and it also works for very simple drug calcs. So let's say that you have a bottle of Valium, because this is just like the other day, transporting a patient, going through DTs, very bad. And we had to give him a bunch of benzos, had to give him a bunch of Valium. And so my bottle of Valium had 50 milligrams, and that was in 10 mLs. All right, so that's my Valium bottle. And so I got this patient, he's going through DTs, he's kind of going crazy, picking at everything. And so my partner and I are like, let's give 10 milligrams of Valium. So we're going to go 10 milligrams of Valium per dose. All right, so I got to figure out how much fluid I'm going to draw out of this bottle. So I'm going to do the big line method, because I'm not giving, when I draw up the medicine, I got my syringe here with the needle and the plunger, because that actually looks more like a knife. We don't want to get flagged by YouTube for having violent videos. So pretend I can't draw a syringe. But we got our syringe and our bottle of Valium. We're going to need to draw some number of milliliters into the syringe to then stick in the patient's arm so he stops being crazy. So we're solving for mLs, and when we're doing this big line method, anything that you've got milligrams over milliliters, you could always flip these upside down. So it's 50 milligrams per 10 mLs, or it's 10 mLs per 50 milligrams. Either way is exactly the same. So what we're going to do is we're solving for mLs, remember? So when we do the big line method, we always put the thing we're solving for right up here in this first spot. So we're going to put 10 mLs per 50 milligrams. Big line. Now we want to give 10 milligrams of Valium, and we got milligrams down here, so we're going to put 10 milligrams up here. Cross out our milligrams. So we got 10 times 10 divided by 50. This is going to give us how many milliliters to give. And now we're going to rewrite some of these. So 50, we could say that that's the same as 5 times 10, right? 5 times 10 is 50. And 10, we're going to rewrite that as 2 times 5. Because 2 times 5 is 10. So now we take this and we say, well, we got a 10 on the bottom and we got a 10 on the top. So we're going to cross this 10 out, cross this 10 out. We got a 5 on the bottom, we got a 5 on top, so we're going to cross those out. And all we have left is 2 divided by 1. Right, we've got everything else, so it's 2 mLs of fluid. That's going to give us that 10 milligrams of Valium. And if you think about this, we go back and just kind of recheck our math in our head, make sure we're right. We want to give 10 milligrams of Valium. There's 50 in the bottle, so that's 1/5 of the bottle. The bottle is 10 mLs, and 1/5 of that would be 2 milliliters. And that's the answer we got, 2 milliliters. So I always like to do that step where I go back and just kind of double check to make sure that what I came up with for an answer actually makes sense. And it does. So anyway, so this is the big line method for doing drug calcs. Again, it works for big, huge problems. It works for little problems. It works for nitro drips. It works for a Valium push on a crazy person. It's all good. works every single time. So I'm going to erase this screen and I'm going to give you a couple of problems to work on, and then you try to do the big line method, see if you get the right answer. So pause the video, do it yourself, and then I'm going to go through and we'll actually solve the problem together. So here we go. Let's do one more of these big line methods. All right, so medical control says that, oh no, this patient's super sick. We want to start an epi drip, and you're told to put 1 milligram of epi in 1,000 cc's of normal saline. You want to give 5 micrograms per minute to get this patient's blood pressure up. We're going to use a 10 drops per milliliter. That's going to be our drip set that we're going to use. And what else do we need to do? Oh, we got milligrams and micrograms, so we need 1 milligram equals 1,000 micrograms. So we're going to set up the big line. And so this is where I want you to pause the video, try to do this yourself, and then unpause the video and we'll work it together. Ready? Pause. Okay, welcome back. I hope you got the right answer. Let's go through this together. So again, we're solving for, we need to know how many drops per minute is going to give us that 5 micrograms. So first off, we're going to start with our drops. So we've got 10 drops per ml. We put our separator in. Got milliliters on the bottom. Got to get rid of that. Oh, remember, milliliters and cc's are the exact same thing. I use those terms interchangeably, so if I screw you up, I really apologize. So we're going to put 1,000 mLs over 1 milligram. And then that crosses those out. Now we got to get milligrams on the bottom. Let's get rid of that. Here we go. 1 milligram, 1,000 micrograms. Got the milligrams out. We got mics on the bottom. We got to get mics on the top. So we got 5 micrograms per minute. Cancel the micrograms out. Yep, we use that, we use that, we use that, we use that. So we used all of our stuff. We've got drops per minute. That's what we're trying to solve for. Everything looks great here. All right, so all right, so we have 10 drops times 1,000 times 5 micrograms divided by 1 times 1 times 1,000 times 1. Now, this one should be really easy to be crossing things out up there, right? So we got 1,000 on the top, we got 1,000 on the bottom. We're going to cross those out. Oh, sorry about that. All right, 1 minute. I didn't mean to put that micrograms back up there. My bad. So we cross those out. We got 10 times 5, which is 50 drops per minute. It's going to get us 5 mics a minute, which is what the doctor ordered to raise this patient's heart rate and blood pressure up. Hope you got the same answer I did. If you have any questions, put them in the comments below. Send us an email on the website. We can make more videos like this or help you out. Hopefully this was super helpful. If you have any questions, that's it. Thanks and have a great day.